So basically, hi, my name is Angel, and this is the signature assignment for calculus. I kind of already started it. I already recorded another video, so I'm just gonna explain through and then continue from then on. So basically, we have I couldn't get my printer to work, so that's why I had to basically write it. And the question goes as follows. A rectangular poster of an area of 6,000 centimeters squared must have blank margins of width 10 centimeters on the top and on the bottom. Here we go, 10 centimeters and 10 centimeters, and 6 centimeters on the sides. Write an objective function of a single variable for the area of the printed region. Inside the margins, be sure to give a reasonable domain, interval of interest, then find the maximum printed rectangular area that can be contained within the margins of the paper. So first off, I decided to do the diagrams. Basically, we are told that the margins of width 10 centimeters on the top and on the bottom, and 6 centimeters on the side. So we have 6 centimeters over here on the both sides, and then we have 10 centimeters on the bottom and on the top. So how do we find the area? Well, we use length times width times length, the same thing. X is going to be our width, and then length is going to be our y. So they both will equal. So therefore, the step one would be just to equal them out. So basically, since we have two sides of each, that would give us x minus 12 and then y minus 20. Therefore, that would be our equation, and then therefore we solve for y. We could solve for y from that. Y equals 6,000 divided by x. Now from that step forward, now that we find this, we have to simplify our ax. We have to remind ourselves that we need to go back over here in that y, and we need to remind ourselves that y is 6,000 divided by x. And so here we can split these two numbers up and multiply by x minus 12. Therefore, we get the following equation, and then after that, after simplifying it, we get 6,240 minus 20x minus 72,000 divided by x. So that would be, this is our equation, which is going to be very important to us in the rest of the question. So basically, how do we find the domain after we already simplified and already found everything that we need to know so far? Basically, we get the width, then we get the length. In order for it to be the domain, it needs to be the x. So basically, we start off with 12. So the interval has to be greater than 12. I'm not looking at that answer right now. And then we get the height and the length. We get the y minus 20 that we put over there. And then we need to basically remember that y is equal to 6,000 divided by x minus 20. So then we add that, then we simplify it, and then we get this. X is less than 300. So we could just highlight that there, because that's important, which would give us, since 12 has to be greater than, well, no, x has to be greater than 12, but less than 300. Okay, so now after that, we find the critical points, which will help us find the maximum. So here, we need to remember that critical points is the derivative of the regular function equal to 0, not to be confused with the inflection point, which is the second derivative. So here, we would do this. We need to find the derivative of the regular function. In this case, the regular function is 6,240 minus 20x minus 72,000. So therefore, how do we find the equation? Well, we need to remember that a constant is 0. Negative 20x is negative 20. So therefore, here we have it, plus 72,000 divided by x squared. And then here we simplify it, and then after that we get the x squared is equals to 72,000 divided by 20, and then we get that x is 3,600 square rooted. And then we are given two answers technically over here, because this basically means that we have 60 or negative 60. Sorry about that. Negative 60. There you go. But Since negative 60 is outside the interval, we need to remember ourselves that it has to be greater than 10 and then 12 and less than 300. So therefore, if this is less than 12, it's not on the interval. The only one that fits this description is 60, since it's between these two. It's less than 300 but also greater than 12. So now this is the part that I was stuck on. Basically, ignore this. Step 5, we need to get the corresponding y and the max printed area. So basically, how do we do that? Step 5, basically we use the regular function that we have, 6,000 over x, which in this case we need to remember that x, we got 60, so 6,000 over 60 equals 100. Okay, in this case is centimeters squared. Okay, so and then the printed area, so to find the printed area is to find the maximum already. Printed area, okay, we will need to use the equation ax minus 12, the regular equation that we used. And then now that we found the y equals 100 and x will equal 60, we now could plug those in. So 60 minus 12 and then 100 minus 20. Okay, we get 80 from here. That's easy. Oh. Sorry, it's just hard to record with the phone and then having the phone in one hand and then writing with the other. So 60 minus 12 is 48, which will guarantee us a equals 380/40. And don't forget the centimeter squared, because that's important also. There you go. So yeah, that's basically how I solved the problem. And basically, yeah, the step 5 on the original paper, and then it doesn't really matter, but step 6 is, so this is my, instead of step 6 I wrote step 5. There you go. So yeah, that's the way I justify my answer, and then there you go. Thank you so much for watching.